All right, example 3. I like this for a couple of reasons. One, we're going to have some fun with it at the end. 2, I like it when questions sort of play with your assumptions. This question, our brains do this. When we see things happen over and over again, we just sort of start to assume that they're going to happen the same way again. They give you an equation and they give you a graph. If you just glanced at this, you would almost instantaneously think that this equation is this graph. But if we read it carefully, it's not. It says the graph of y equals 1 over negative 2x squared minus 0.5 was reflected, and its image is shown. So I'm going to put a blue box around this. This isn't part of the question, but just pointing out that this would have been the original graph. Well, more or less. Because the original one had to have been on the bottom, it was reflected over the x-axis or in the x-axis. And the red graph is the new graph. And we have to come up with the equation of the new graph. Now, first thing I would do, I would think about this, is it horizontal or is it vertical? Vertical, right? Things are moving up and down. It's vertical. And because it's vertical, everything vertical is outside. So in my function notation, I would think of this. Y equals outside of negative f of x. The f of x in this notation really means the original one that you started with. So our equation, and since it's in red, I'll write it in red. Our equation, what was the original? This was the original. And we need to put a negative out in front. And that's all this question is asking. But I'm going to take this question and put it up a little bit more difficult level. Sort of, sometimes you do something like this was a short answer question, perfect. 100% right there. But sometimes it's a multiple choice question. And I'm actually going to give this to you like a multiple choice question from an AP exam. If some of you are planning on taking calculus AP next year, then this is what they sort of how they can create another level of multiple choice. What they'll do is they'll give you 3 options. So I'll do option 1 in black. And option 1 in black looks like this. Y is equal to negative 1 over 2x squared plus 0.5. And then option 2, I'll do in orange. And they would say y is equal to negative 1 over negative 2x squared minus 0.5. And option 3 in green, y is equal to 1 over 2x squared plus 0.5. And then the multiple choice would say, like, all of the above, none of the above, 1 and 2, 1 and 3, 2 and 3, only 1, only 2, only 3. Oh. Basically, are all of these right? Are some of them right and some of them wrong? So I want you to look at all 3, and we're going to do an anonymous vote on which ones you like. If you think the black one is right, when I say, who likes the first one, your eyes will be closed, you'll raise your hand. If you like the orange one, you'll put your hand up on the orange one. And we'll put our hand up with the green one. Maybe I'm tricking you. Maybe they're all wrong. I don't know. Oh. And this is what makes the AP exam challenging, because not only do they look at, do you know the idea? The idea is the red part, that this is a vertical reflection, so the negative would be outside. But then, do you also know your algebra skills that you're confident to recognize when things are equal and when they're not? Okay, you ready to vote? Just go with your gut, what you think. Close your eyes. If you like one, put your hand up. All right, close your eyes. The black one, do you like the black one? Put your hand up in the air. All right. Orange one, the second one, you like the orange one? Put your hand up in the air. All right. And green one, if you like the green one, put your hand up in the air. Hey. All right, you can open your eyes. Nobody else. Okay, good. The one that was like the most was the black one. Unfortunately, the black one is wrong. We'll talk about that. In the other class, only one person liked the orange one. A few more people like the orange one in this class. The orange one is actually good. And the green one, also a few people like the green one. And the green one is good. Okay. You thought I was going to make an X, didn't you? I tried to make it look like I was going to make an X. So what happened, and what is your brain doing if you are making those mistakes? Well, it's actually quite easy to tell you what your brain was doing. You're mixing up two simple math ideas, and you're wondering when I can use one and when I can use the other. The math idea that you're mixing up is you're seeing a negative outside of the bracket, and you're thinking of distribution. And what I mean by distribution is, right, if you had negative 2 times x plus 3, right, you know that you would multiply that negative 2 by both of those and get negative 2x plus 6. That's what you're thinking about, but does the negative here go to everything? No, because this is a fraction. So now we have to think about multiplying also and multiplying fractions. So if I'm multiplying by a fraction, this negative outside is a negative 1. That's like having negative 1 over 1 or 1 over the negative 1 on the bottom. It's not the same as having negative 1 over negative 1.
That would just be positive.
That would just be positive 1, but that's what the black one did. I multiplied the top by the negative 1 and the bottom by a negative 1, which means I actually multiplied by positive 1. So the orange one said, well, if you kept the negative on the top, multiplied the top by negative 1 and the bottom by positive 1, that would match up perfectly. Or if I put the negative on the bottom, because that's still negative 1, then I would get the green. So again, just a little bit of algebra stuff, but again, that's another place where our brain plays tricks on us sometimes. And this one in particular, I had a negative outside the brackets. When do you see negatives outside the brackets? Most in distribution. It's like I was setting you up to try that method, right? So we have to think about those things. And sometimes by making those mistakes, we can understand them a little bit better. Okay, now, also fun in this question is I want you to put a star beside number 12, because I think number 12 will be the first time we get a real problem-solving question. Okay? Now, one of the things that you're supposed to develop in all of your math classes is skills in problem solving. And usually what a problem-solving question does is it takes information from a bunch of different things that you know and puts them together in a question you've not seen before. And I'm going to put problem-solving questions on your test as well, and I'm not doing it to be like, ooh, I'm going to be mean and trick you and give you a hard question. No. The purpose is we need to develop the skills, because at the end of the year, you're going to write a provincial exam that I didn't write. In fact, you open it up on the day is the same day that I open it up to see. And there might be, whoever makes the exam might word something a little bit different than I do. Or just the context is something that we didn't see in our class. So we need to develop the skills when we come across things that are new. How do we develop the skills to do those? So try number 12 for sure for tomorrow's class. We'll start tomorrow's class by discussing it, okay? And discussing how you can use some of your problem-solving skills. You're going to need to know some stuff about parabolas from previous years, so you're going to have a little review of your parabolas. to help you with number 12.